An outbreak of coronavirus infections in the Wuhan province of China in December 2019 is threatening to emerge as the next pandemic. At current count, over 40,000 cases and 600 deaths have been reported in China and over 300 cases in 25 other countries. Unofficial modeling studies by a number of institutions claim infections of over 150,000. The alarming speed of transmission is in part because the virus spreads through the air and by touch. Using the power of 3D medical animation, this video covers what is a pandemic, how this coronavirus is spreading, how coronavirus attacks the body, and what are recommended precautions to take for protecting against epidemics. Pandemics indicate outbreaks of disease that spread to cover an entire region or the world. A pandemic can result in massive loss of life. In the last 100 years, there have been 4 global pandemics, the worst with the 1918 influenza pandemic, resulting in an estimated 50 to 100 million deaths. While no global pandemic has been born from the family of coronavirus, 2 regional epidemics have resulted from this family of viruses. They include severe acute respiratory syndrome, or SARS, and Middle East respiratory syndrome, or MERS, in 2001 to 2003 and 2012 to 2015, respectively, and resulted in over 1,500 deaths. Much is yet to be known about the 2019 novel coronavirus. An early study of 99 infected showed a high mortality of 11%, similar to SARS, and ICU admission rates of 23%. An earlier study described a virus pathology with an 8-day incubation period, a week of infection, followed by a potential escalation to hospitalization and intensive care over another 8 to 10 days. Other indications put the mortality rate closer to 4%. The virus has, as of February 6th, over 40,000 confirmed cases in China alone, with almost 200 cases in over 25 other countries. However, Dr. Jonathan Reed from the UK believes that the numbers of actual cases is far greater and has estimated between 170 to 300,000 by February 9th. This is because symptoms can be mild and escape reporting and testing. What's more, in stark contrast to SARS, some patients may be infectious in their incubation period before the onset of any symptoms. Mechanism of action of coronavirus. The 2019 novel coronavirus is a newly discovered strain from the coronavirus family that causes respiratory disease. Humans have long been infected by coronavirus, as it is one of those responsible for the common cold. It is a contagious viral infection spread through inhalation or ingestion of viral droplets. As a result, coughing and sneezing and touching infected surfaces are primary sources of infection. The structure of coronavirus has multiple parts. Inside the virus lies the genetic encoding that allows the virus to hijack human cells and turn them into virus factories. A protein encapsulates the genetic material known as the viral envelope. On the surface of the viron are S and HE proteins. The structure of the 2019 novel coronavirus is a mutation. For more information on this, see the link below. The large S glycoproteins are used by the virus to gain entry to human cells. They most likely attach to angiotensin-converting enzyme 2 receptors on the cell membrane, allowing the virus entry. The exact mechanism for this is not known. Most likely, as shown here, the human cell ingests the virus in a process known as endocytosis. Once inside the cytoplasm, the endosome opens to reveal the virus's genetic material, a single-stranded RNA. The virus hijacks the cell's machinery to replicate the RNA in N proteins and uses the endoplasmic reticulum to form its M protein outer layer and the all-important S protein. After replication, the virus is carried by the Golgi bodies out of the cell in a process known as exocytosis, so that it can infect other cells. Meanwhile, the stress of viral production on the endoplasmic reticulum eventually leads to apoptosis, or cell death. It should be noted that the mechanism of action for 2019 novel coronavirus is unknown. However, scientists in China have sequenced the genome, while others have used the sequencing to visualize the structure. There is currently no cure or vaccine for the 2019 novel coronavirus, and treatment is only supportive. Therefore, preventing transmission is paramount. As an airborne virus, recommended precautions are similar to those for preventing the flu. This includes washing hands regularly with soap and water for 20 seconds, covering sneezes and coughs with the inside of the elbow, refraining from touching high-contact surfaces like railings and doorknobs. If you use tissues, throw them away immediately. Avoid close contact with people who are sick. For more info on precautions and best practices, see the list of references below. The pandemic risk of the novel coronavirus is very real. However, biology has advanced greatly in the 15 years since SARS, and so has communication between biologists and governments. China has taken monumental efforts to contain the spread of the virus. Also, some existing and experimental drugs are offering hope for treating the infection and improving outcomes. But even still, infection control habits remain paramount if humanity is to stave off a full pandemic. For further information, see the resources listed here.
These epidemic events are getting more and more disruptive to health and to economy. And the reason we called it Event 201 is we knew eventually one of these days, one of those events would be the big one. And that big one would really challenge our capacity to respond. And to respond to the big one, we do need to have all hands on deck. Participants are confronted by a hypothetical scenario that presents to them the challenges of a response. So we will say, here's a hypothetical disease outbreak. This is the way it might be evolving. And these are some of the challenges that you'll see that you'll have to address to address the disruptions that you're seeing to your healthcare system or to your organization. All stakeholders realize pretty quickly just how underprepared we are and just how much is possible when we work together. And that the individual actions of any government or company won't add up to a proper global response. I think if we're honest with ourselves, collectively, the international community has never done enough to respond to global health security challenges. That we knew before COVID that the world was underprepared for biological risk. When we walked into the room in New York, if you would have asked, do you think the world is prepared for a pandemic? I think everyone around that table would have said no. But it's when they walked out, I think is when we really knew that if we are going to get ready, we need to have operationalized and integrated public-private cooperation that we haven't seen before.
Hello, this is Jens Varoufakis on behalf of DiEM25, our Democracy in Europe movement, with some thoughts about the impact of, the epidemic, not just on our daily lives and our health, but primarily on our economy, on our politics, on our morality, on the way we deal with asymmetric or symmetric threats. This epidemic, like all epidemics, has these two separate but of course related realms. One is the impact on our health, on the way it changes our lives with isolation, with the cessation of normal activities, the fear of illness, but at the same time there is the epidemic that spreads throughout the political economy of global capitalism. Undoubtedly, the coronavirus is going to accelerate the post-2008 crisis. Now, don't let anyone tell you that that crisis ended and now we have a new one. The 2008 crisis never ended. It morphed into different forms. It traveled from one continent to another. It took different forms, but nevertheless, it has always been with us. The world never went back to some kind of equilibrium after 2008. Capitalism is unrecognizable today by means of terms of references from the period before 2008. What the coronavirus has done is it has deepened and accelerated the never-ending, non-stop crisis that began in 2008. If you think about it, the reason why there's been a semblance of normality, of recovery after 2010, 2011, was because central banks and governments took it upon themselves to refloat the financial markets and to rebuild the circuits of financialized capital by printing trillions and trillions, mountain ranges of money, and throwing them at the 0.1% at corporations that were already full of money. Take Apple, Google, and so on, borrowing free money from the Federal Reserve in the United States, for instance, in order to buy back their own shares. All that was doing was boosting inequality massively, stabilizing financial markets, but at the same time depleting all serious investment in good quality jobs, in labor, in health, in education, in the green transition that this planet needs. This is why there's been so much discontent even before COVID-19 arrived on the scene. So when COVID-19 arrived on the scene, it found a global capitalism that was sitting on a gigantic bubble of private debt that had been minted by central banks on behalf of financial capital. So the problem is not stock exchanges going up and down. Every catastrophic collapse of the stock exchange can easily be followed by a remarkable boost, the indices going through the roof. But even if the central banks of the world, the Federal Reserve, the Bank of Japan, the Bank of England, the European Central Bank, even if they manage to refloat capitalism again, in the same way that they did in 2008, 2009, that is not going to bring us to where we were before COVID-19. And that is so for a very, very simple reason. COVID-19 has pricked the bubble on which financial capitalism was sitting up until now. So even if the financial markets are refloated once more, the level of investment is going to be even lower than it was a few months ago. And let us not forget that a few months ago, the level of investment, especially in important stuff, in things that humanity needs, tangible goods, green energy and so on, the level of investment in relation to the available liquidity and savings has never been lower than it was even before the coronavirus hit. Imagine what it will be like afterwards. Now, what defenses does financialized capitalism have today compared to 2008? This comparison is quite instructive between 2008 and 2020. In 2008, two things saved global capitalism: the Federal Reserve, the Central Bank of the United States, and China. Of course, later governments in Europe, the International Monetary Fund and so on, did much in order to complete the job that the Fed and China began by shifting cynically gigantic amounts of losses from the private banks onto the shoulders of the weakest taxpayers, what we in DiEM25 refer to as socialism for the very, very few, for the bankers, and harsh austerity for the many. But it was China and the Fed that were the pillars that kept financial capitalism going. Both these pillars are today highly depleted. Coronavirus started in China. It damaged significantly the capacity of the Chinese political economy to produce surpluses. It shut down factories. It reduced the growth rate below zero. And therefore, it did exactly the opposite to China compared to what happened with the financial crisis in 2008. China is not today in a position to do what needs to be done in order to boost aggregate demand in Germany, in Holland, in Japan, in the United States. China is a patient now. It is not the medical provider. The Federal Reserve could potentially repeat that magnificent feat of 2009 because, unbeknownst to many people, in 2009 the Federal Reserve extended what is called in the business dollar swap lines to the European Central Bank and to the Bank of Japan and to the Bank of England and to many other central banks. Effectively, the Federal Reserve said to them, we will give you as many dollars as you need in order to cover your positions, your bets in dollars that had gone up in the air. Trillions of dollars were provided by the Federal Reserve to the inane, ridiculous bankers of Germany, of France, of Greece, of Japan, and so on and so forth, and therefore refloated them. They could do this again now. But there are two problems. First, as I said before, this is not going to restore the capacity of capitalism to invest in important things and in good quality jobs. That capacity is going to be lessened, even from the ridiculously low levels that we had before the coronavirus hit. But there's another problem. It's called Donald Trump in the White House. Will Mr. Trump sit idly by watching the Federal Reserve provide swap lines to Germany, to the European Central Bank, to Japan, to China, if needs be? I very much fear that he's going to try to attach strings to any such dollar swaps. And if you do try to attach strings and to try to use this as a negotiating tool with the European Union or with China, those strings destroy the efficacy of the dollar swap lines. It sounds like a technical issue. It's not a technical issue. It's a question of brute force. In 2008, 2009, the Federal Reserve used the exorbitant privilege of having the capacity to issue dollars in order to save financial capital in the rest of the world. Is Donald Trump interested in doing that? If he's not interested in doing that, the repercussion would be very simple. We're going to have an even deeper crisis, a deeper recession with tangible effects on the lives of people from Hong Kong and Shanghai all the way to Finland, Portugal, Iceland, everywhere. This is why this epidemic is of great significance to real people's lives across the world. If there are any lessons to be learned from this latest development in the global political economy, it is twofold. Firstly, the importance of public health systems, and secondly, how crucial it is to use public finance for the benefit of the many, not the few. I'll begin with public health. Have you noticed that private health providers resemble rats that are jumping off the sinking ship? Have you heard anything being discussed regarding the contribution of private hospitals and private healthcare during this crisis of the coronavirus induced dynamic? No, they are nowhere to be seen. All the discussion in the media, the very same media that before the coronavirus hit were going on and on about private-public partnerships and how important it is to push money towards private healthcare because that's more efficient than public healthcare. That's the narrative of the privileged, if you want, which dominated for so many years, decades, in the West after Thatcher and Reagan. The very same media that were extolling the virtues of privatization of hospitals, of private-public partnerships and so on, today only talk about the importance of utilizing the public health service in order to save our bacon, to save our lives, and to ameliorate the effects from the coronavirus. I'm going to make a very strong statement. I'm not just going to say that private health care is inefficient. No, it's not just that they are inefficient. They are destructive. Every euro, every yen, every dollar which is being spent on private health services detracts, not only does not add enough, but detracts from the capacity of humanity to deal with pandemics. It is about time we eradicate private health service. There is not even a liberal argument in favor of private health insurance, of private health systems. They do not work even by the standards of liberal economic, pro-capitalist, pro-market thinking. And then there is, of course, fiscal policy. It is interesting that even the Federal Reserve, especially the European Central Bank, under its new president, Christine Lagarde, who, by the way, gets a score of precisely 0 out of her first attempt to intervene a few days ago with a press conference in order to steady the nerves of the markets and to show that the European Central Bank will do whatever it takes in order to save, again, the euro's bacon and to stabilize the economy. She failed spectacularly. She made 2 gaffes. I'm not going to go into them. Close the parenthesis on this. Even she, nevertheless, came out and said, look, our ammunition as a central bank has been spent over the last 10 years. She didn't use those words, but that's what she meant. We have refloated financial markets. There's nothing we can do. Think about it. The European Central Bank has a negative interest rate of minus 0.5%. It keeps buying all sorts of debt, private debt, public debt, and so on. It is at the end of its tether. And she, on behalf of the extremely conservative European Central Bank, looked at prime ministers and presidents in the eye and said, it's your job now to borrow and spend. And what are they doing? It is astonishing. The other day there was a Eurogroup meeting, the meeting of the European Union's finance ministers of the countries that are using the euro. And it was a teleconference. They decided that the coronavirus poses a clear and present danger of a massive recession in Europe, that it is a highly significant threat to European economies. So much so, the urgency was so great that they decided to do absolutely nothing. They decided that they are going to monitor the situation, that they're going to be watched. You see, what happens is the Eurogroup and the European Union, and in particular the Eurozone, is so terribly structured that they are on autopilot. They simply follow particular rules that cannot be followed without wrecking our economies. This is not just a reflection of inanity, it is that as well, but it is a reflection of a system that has been created in order to prevent governments from acting on behalf of society. That is, if you want, the neoliberal kernel inside the Eurogroup. They're talking about doing whatever it takes within the fiscal compact, which means nothing, because the fiscal compact is like an iron cage of austerity from which you cannot escape. And you need to escape from an iron cage of austerity if you're going to do anything about the green transition, which is so essential, or about dealing with the wholesale recession that the coronavirus is going to bring again to a Europe that has fallen behind the rest of the world as a result of such a stringent austerity package that began in Greece in 2010 and then spread out like a cancer out of control throughout the European Union. So let's recap. We live in a world which is not governed in a way that allows us to see any light at the end of the tunnel regarding the handling of capitalism's never-ending crisis, which the coronavirus has now turbocharged. The European Union has never been less competent than it is now. The European Union has never been less capable of acting as a union than it is now. DiEM25's proposals over the last 4 years since our inception about a common investment policy based on an alliance between our investment bank, the European Investment Bank, the European Central Bank, about a universal basic dividend, about a carbon tax, and about a social equity fund, the purpose of which will be to energize both private capital and public finance or public financial instruments in order to take the mountain ranges of liquidity that exist in our financial circuits and put it into good use, press them into public service in terms of public health, in terms of the green transition, in terms of creating good quality jobs. That agenda of DiEM25 has never been more pertinent and has never been more urgent than today. We can see that all the arguments of the liberal establishment, effectively business as usual, it took one little virus in order to wreck them. We've seen that the idea of Lexit, of a left-wing exit from the European Union, all it did was it strengthened people like Boris Johnson, and the right-wing exiteers, the nationalists, the ones who want to build taller walls between our countries, and the ones who are benefiting politically by turning one proud nation against another, one person against another, one member of the working class against another member of the working class. We have seen the inability of existing nation-state-based political parties to come together and to issue a common manifesto, a common policy agenda for the whole of the European Union. DiEM25 is the only one that has done it. We did have our Green New Deal, we do have it. The Green New Deal can very easily be seen as the only foundation on which we can build simultaneously the investment in the green transition, which is essential in order to keep us breathing on this planet, and the public health services that are essential for dealing with a pandemic like this one. On behalf of DiEM25, Carpe Diem, as we say, the world is going to become a worse place very, very soon, but it is up to us to fight in the context of a transnational movement like what DiEM25 is building in Europe, like what the Progressive International is doing across the world. We'll have more to say about this later on, especially in September when we reconvene the Progressive International in Reykjavik in Iceland. It is essential that we keep struggling because our ideas and our blueprint make sense, they're rational, they're immediately implementable. All we need to do is to change the politics of a continent, Europe, that is finding it impossible to reproduce itself under the present circumstances without the fundamental, profound, transnational, progressive politics that we advocate as DiEM25. Thank you.
Come on. See, the important thing is that you stay at home because there's a curfew now. Okay, no one is allowed out, especially someone that is like 72 years old. After you're 65, you're not allowed at the house anymore in California. So we stay home and we eat here, right? Oh yes, that's yummy. I eat with the whiskey and there's Lulu. Lulu loves carrots, whiskey loves carrots. I just had my little bit of vegan food. Oh, that was yummy, huh? Oh, see, that's what we do. We don't go out, we don't go to restaurants, we don't do anything like that anymore here. We just eat with whiskey and with Lulu. We have a good time, we get entertained. Look at that beautiful smile she has, huh? Oh yes, oh yes, the yummies, huh? And we have a good time eating here together. So much more fun than going outside. No more restaurants, okay? No more restaurants, forget all that. Public gatherings, restaurants, and all those gymnasiums out the window. We stay home. Okay, whiskey, huh? You, and I have you in my neck. Mwah. Yeah, whiskey. And you, I have you too. Now I have both of you. Look at this picture here. Yeah. No biting. Okay, you got to get along. Because we're in very small quarters. We have a very small house here. Yeah. Good girls. I love it. Good girls.
It was New Year's Eve 2019 when health officials in China admitted they had a problem.
Health authorities have activated their most serious response level
after an outbreak of a new type of viral pneumonia
in central China.
A rapidly growing number of people were developing a dry cough and fever before getting pneumonia. And for some, it turned fatal. Doctors have named the disease COVID-19, or coronavirus disease 2019, indicating that a type of virus is causing the illness. When they tried to trace its origin, they found a likely source: this food market in Wuhan. Out of the first 41 patients, 27 had been here. It wasn't conclusive evidence, but Chinese officials quickly shut down the market. They had seen this happen before at a place just like this.
Health officials are trying to get a grip on an alarming outbreak of SARS.
The virus originated in mainland China.
Has spread across the country.
The disease had been festering for months in southern China.
In 2002, a coronavirus had emerged at a very similar market in southern China. It eventually reached 29 countries and killed nearly 800 people. Now, 18 years later, this coronavirus is in at least 71 countries and has already killed over 3,100 people. So what do these markets have to do with the coronavirus outbreak, and why is it happening in China? A lot of the viruses that make us sick actually originate in animals. Some of the viruses that cause the flu come from birds and pigs. HIV/AIDS comes from chimpanzees. The deadly Ebola virus likely originates in bats. And in the case of the 2019 coronavirus, there's some evidence it went from a bat to a pangolin before infecting a human. While viruses are very good at jumping between species, it's rare for a deadly one to make this journey all the way to humans. That's because it would need all these hosts to encounter each other at some point. That's where the Wuhan market comes in. It's a wet market. A kind of place where live animals are slaughtered and sold for consumption.
It was not a surprise at all, and I think that it was not a surprise to many scientists.
Peter Lee is a professor and expert on China's animal trade.
The cages stacked above one over another. Animals at the bottom are often soaked with all kinds of liquid, animal excrement, pus, blood, or whatever the liquid they're receiving from the animals above.
That's exactly how a virus can jump from one animal to another. If that animal then comes in contact with or is consumed by a human, the virus could potentially infect them. And if the virus then spreads to other humans, it causes an outbreak. Wet markets are scattered all over the world, but the ones in China are particularly well known because they offer a wide variety of animals, including wildlife. This is a sample menu reportedly from the market in Wuhan. These animals are from all over the world, and each one has the potential to carry its own viruses to the market. The reason all these animals are in the same market is because of a decision China's government made decades ago. Back in the 1970s, China was falling apart. Famine had killed more than 36 million people, and the communist regime, which controlled all food production, was failing to feed its more than 900 million people. In 1978, on the verge of collapse, the regime gave up this control and allowed private farming. While large companies increasingly dominated the production of popular foods like pork and poultry, some smaller farmers turned to catching and raising wild animals as a way to sustain themselves.
At the very beginning, it was mostly peasant household backyard operation of turtles, for example. That's how wildlife farming started to get off the ground.
And since it started to feed and sustain people, the Chinese government backed it.
So it was imperative for the government to encourage people to make a living through whatever productive activities they can find themselves in. So you can lift yourself out of poverty. No matter what you are doing, that's okay.
But then in 1988, the government made a decision that changed the shape of wildlife trade in China. They enacted the Wildlife Protection Law, which designated the animals as resources owned by the state and protected people engaged in the utilization of wildlife resources.
That's one of the most devastating problems of the law, because if you designate the wildlife as a natural resource, that means it is something you can use for human benefits.
The law also encouraged the domestication and breeding of wildlife. And with that, an industry was born. small local farms turned into industrial-sized operations. For example, this bear farm started with just 3 and eventually grew to more than 1,000 bears. Bigger populations meant greater chances that a sick animal could spread disease. Farmers were also raising a wide variety of animals, which meant more viruses on the farms. Nonetheless, these animals were funneled into the wet markets for profit. While this legal wildlife farming industry started booming, it simultaneously provided cover for an illegal wildlife industry. Endangered animals like tigers, rhinoceroses, and pangolins were trafficked into China. By the early 2000s, these markets were teeming with wild animals when the inevitable happened.
The latest on the deadly SARS virus, the worldwide death toll up again today.
China has reported more than 1,400 cases of infection nationwide.
It is what health officials have feared all along.
In 2003, the SARS outbreak was traced to a wet market here in southern China. Scientists found traces of the virus in farmed civet cats. Chinese officials quickly shut down the markets and banned wildlife farming. But just a few months after the outbreak, the Chinese government declared 54 species of wildlife animals, including civet cats, legal to farm again. By 2004, the wildlife farming industry was worth an estimated 100 billion yuan, and it exerted significant influence over the Chinese government.
Wildlife farming industry was tiny in China's gigantic GDP, but the industry has enormous lobbying capability.
It's because of this influence that the Chinese government has allowed these markets to grow over the years. In 2016, for example, the government sanctioned the farming of some endangered species like tigers and pangolins. By 2018, the wildlife industry had grown to 148 billion yuan and had developed clever marketing tactics to keep the markets around.
The industry has been promoting these wildlife animals as, tonic products, as, bodybuilding, as sex enhancing, and of course as disease fighting. None of the claims can hold water.
Yet these products became popular with an influential portion of China's population.
The majority of the people in China do not eat wildlife animals. Those people who consume these wildlife animals are the rich and the powerful. A small minority.
It's this minority that the Chinese government chose to favor over the safety of the rest of its population.
These parochial commercial interests of small number of wildlife eaters are hijacking China's national interest.
Soon after the coronavirus outbreak, the Chinese government shut down thousands of wet markets and temporarily banned wildlife trade again. Organizations around the world have been urging China to make the ban permanent. Chinese social media, in particular, has been flooded with petitions to ban it for good this time. In response, China is reportedly amending the wildlife protection law that encouraged wildlife farming decades ago. But unless these actions lead to a permanent ban on wildlife farming, outbreaks like this one are bound to happen again. For a bunch more information about China's wet markets, viruses, and wildlife, we have an episode on our Netflix show called The Next Pandemic Explained. It talks about why a coronavirus could spark the next pandemic and what the world's experts are doing to stop it. That's on our Netflix show Explained. Check it out.
My name is not normally this large, but since it was a TED Talk, they adopted the TED format. So my topic's a little different, but I think it does fuse the peace box and the war box that we heard earlier, because it's very much a dimension of global security. And I would argue, and I hope you'll agree at the end of my talk, this is a domain which is very much an emergent threat, but neglected. So it is infectious disease at one level and its relentless dynamics. We are facing old foes resurgent. Most dangerous place now in America is a hospital in terms of antibiotic-resistant infections. If someone had to say to me, what do I consider to be the biggest single infectious disease threat, it is still pandemic flu. We have the much publicized Hollywood apocalyptic dimension of new diseases like Ebola. Things move fast around the world, and we must, of course, add to this bioterrorism, and as I'll end with my talk, new technologies will in fact alter this entire dynamic. But we again have a silo problem, and that is the fact we've tended to look at human health separate from animal health, separate from ecosystem health. They're inextricably linked. Most of the diseases that now affect us are called zoonoses. They come from animals. At the same time, strategically, how do we feed 9 billion people going forward? Of the 6 billion people with us today, 2 billion of them don't have access to clean water. Almost 1 million don't have access to adequate water. We're depleting natural resources. New patterns of agriculture are giving rise to new patterns of disease. Climate change is altering vector spread, and it would be generous to say that the World Health Organization even has a biosurveillance. Let us euphemistically call it fragile at best. But it is this, disease burden, apart from its horrific impact on those affected, is in fact a source of global instability. Inadequate infrastructure, so there is Ebola. At the same time, distrust of authorities, an individual who escaped from a quarantine facility being bundled back in. The dreaded triad of poverty, illiteracy, combined with infectious disease, the omnipresent issue of famine. 40 million orphans, courtesy of HIV in Africa, has fueled the child soldier problem. We could, in fact, for the refugee crisis, actually put the Congo there rather than the much more publicized one in Europe. But either way, the military implications of this are substantial, either by humanitarian intervention or when the military has to be deployed to a hot zone, courtesy of the economic, political instabilities that these types of burdens will create. At the same time, in the world of global transport, with almost 1 billion people moving around the world, we have rapid spread. We had 5 cases of Ebola passively transferred to the United States, at the same time that 1.5 million cases of chikungunya were spread in the Caribbean basin. The reason most of you didn't know about it is because it's too complex a word for most newscasters to pronounce. But we have to basically look at this in terms of the context of a comprehensive global biosurveillance. Zoonoses are the biggest single challenge we face, not just pandemic flu. HIV had its origins in monkeys and primates. West Nile, a complex interplay between animals. MERS in the Middle East. Ebola, probably the primary vector and reservoir source is bats. A huge bushmeat food chain in Africa. And of course, the tragedy that we're seeing now unfolding courtesy of Zika with microcephalic children. Bottom line is what's out there. Because we have almost 1 million people a day moving into urban zones. 52% of the world now lives in urban zones, and a significant fraction of those live in slums. The worst possible situation, high population density for the transmission of infection, and those urban megapoli, particularly in Asia, Africa, and South America, are pushing out into virgin ecoterrain, where in fact we there find these new exotic organisms that we've never seen before, the zoonotic threat, courtesy of urbanization, and of course, once again, inadequate infrastructure. Military operations must consider operating in collapsing urban environments. The Joint Urban Operations Doctrine gives scant attention to this. It is not simply the lessons of Iraq and Afghanistan, it's more a Mogadishu on steroids. How do you protect the force when deployed into a hot zone, as they were in the case of Ebola? But it is a collapse in civil disorder will be the norm in these urban megapoli into which they will be deployed. And if you look at the quadrennial defense review, this issue barely surfaces at all. If there's one thing where we should be investing, it is biosurveillance, our capability to understand what's out there, and there are 3 dimensions to that, as there is in any intelligence. How do you find out what is out there to profile it? Finding the genetic signatures of these new organisms, having rapid, deployable point-of-care mechanisms to detect it, and then to have real-time situational awareness to respond to that threat. We have to sample broadly. One always sends one's best graduate students to sample the nostrils of seals, but that means if their paper only gets a B. The bottom line is the fact that we have this broad spectrum of sentinel species. Real time, the beast on the hip has become a very real mode of reporting information. Upload that information for real-time intelligence, whether it be the distribution of infection in Washington, D.C., the availability of hospitals, movement, and so forth. Critical issue to move from ground zero data to real-time intelligence. But if you don't have drugs and vaccines, isn't this a telling picture? There is a physician from the bubonic plague in the 15th century. Note the resemblance when we have no drug and no vaccine in Liberia, a telling similarity. It's a societal choice. Do we want vaccines or Viagra? We've basically got out of the business of making new vaccines simply because we're not prepared to pay for them. If we're going to deal with these issues, we're going to have to re-incentivize industry to re-engage. Industry spent over $110 million engaging on Ebola, and then suddenly it's out of sight, out of mind. That's $110 million they have to bear as a loss on their balance sheets. We have to be far more proactive. Out of sight, out of mind by definition. Comfort and complacency are always the enemies of vigilance and preparedness, whether it be nations, corporations, or sports teams. 1947, penicillin. It was predictable that in 2010 we would have a growing antibiotic resistance problem. We now have the first organisms with us which are resistant to every single antibiotic that we have. Slow mobilization. Polio was a national priority. We mobilized all skill. It was a war against polio. Now, so there is a national blueprint for biodefense from Tom Ridge and Joe Lieberman, which I was pleased to serve as a member of that. It's a devastating indictment of the absolute lack of preparedness of this nation, indeed global preparedness against whether the assault be natural organisms or bioterrorism. And since 9/11, we have basically dissipated billions of dollars with no real response and, most importantly, no accountability for that. And then there's the future, where I basically live. The question was raised earlier this morning. We're in the era of digital biology, it from bits. Every piece of DNA is merely digital. I can send it around the world and have a virus synthesized on the other side of the world the next day. That's where we are. At the same time, dual-use technologies, the same information being used for beneficent purposes and malevolent purposes. That threat is growing, but it's no longer bugs. It's the circuit diagram of every one of the 276 different cell types that exist in your body. That's obviously the future of precision medicine, but it is also the future that if we know the circuit diagram, we can screw it up. And obviously, one of the obvious issues of great concern is that in relation to cognitive and sensory functions in the brain. And if we think we are alone, the biggest genetic center in the world is in China. That's the Beijing Genome Institute, with a powerful computational capacity. At least the intelligence community understands this. This is D&I Clapper's recent report, and gene editing now makes the top 6 threats that he views as the most existential. But what we have to bear in mind, ladies and gentlemen, is the fact that this is a technology diffusion, which was emphasized this morning. It's quick, it's rapid. High school students can do some of this now. What a person won a Nobel Prize for 20 years ago, my grandchildren are doing. The chemical and biological weapons convention is totally outmoded. This is not some saturation stuff dropped from the sky. This is very subtle bioengineering, and this is here, ladies and gentlemen, today. This is not something for tomorrow. So I've given you a very superficial surf across a very broad, multidimensional challenge. We have to think about health now on a global scale, not just about us, anthropocentric dimensions, but the interrelationship of human, animal, and ecosystems. Globalization and urbanization are giving rise to new disease patterns. Those will inevitably result in military intervention, whether humanitarian or overt conflict. We need to have global biosurveillance capabilities. Private sector must be re-incentivized to invest in this area. And the symposium in its own right, perhaps next year in Future War, is where will synthetic biology and the expanding dual-use threat take us. And we indeed have major gaps in our preparedness, both at the level of strategy, policy, and capabilities. So with 11 seconds left, I hope that that is at least a superficial surf across a fascinating subject. Thank you.
At first, you might think it's a cold, and it could be, but COVID-19 could escalate. Here's what you need to know. According to the World Health Organization China Joint Mission on COVID-19, as of February 20th, 80% of laboratory-confirmed cases were mild to moderate, 14% were severe, and 6% were critical. Just to be clear, a mild case of COVID-19 is not like a mild cold. The symptoms will still be pretty severe. Anything less than needing oxygen puts you in this category. Severe cases do need supplemental oxygen, and critical ones are defined by respiratory or multi-organ failure. The symptoms, treatments, and timelines of having the disease vary, depending on which category patients fall into. So let's break down what having COVID-19 looks like day to day for each level of severity. It can take as few as 2 or as many as 14 days after being exposed to the novel coronavirus for the first symptom to develop. This is when it might feel like a cold or the common flu. Many patients develop fevers early on. The World Health Organization China Joint Mission saw that about 88% of people who had COVID-19 had a fever. Another study out of China showed that while only 44% of patients had a fever on admission to a hospital, 89% eventually developed one. But there have been some cases that led with gastrointestinal symptoms. Diarrhea, nausea, vomiting, and/or abdominal discomfort may appear a couple of days before respiratory symptoms. This isn't the norm, though, because COVID-19 is a respiratory disease. That means for most patients, the virus will start and end with the lungs. In the early days of infection, the virus invades lung cells. Specifically, this can damage the cilia, the hair-like projections that move around to keep airways clear of mucus and debris. When cells get infected, they die and shed off, adding to the debris and hindering your body's ability to keep stuff out of the lungs and trachea. The inflammation causes damage, and damage causes more inflammation, and this cycle could continue until there's no healthy tissue left. And inflammation might explain why a dry cough is one of the most common symptoms. Same goes for shortness of breath and phlegm production. Other symptoms that can appear around this time are fatigue, sore throat, headache, joint or muscle pain, chills, and a runny nose. By day 5, patients with pre-existing conditions might find that they have trouble breathing, and it usually takes about 7 days for a person to go to a hospital. Mild cases, though, usually clear up by this time. But those with moderate to critical cases will have developed pneumonia, which can range from non-life-threatening to severe. Recovery time for these patients could be anywhere from a few days to weeks. For some severe and critical cases, though, symptoms can escalate into acute respiratory distress syndrome. ARDS is an illness that happens when fluid builds up in the lungs. Inflammation triggers a flood of immune cells that are meant to target the infection. They're usually isolated to infected areas, but sometimes the body goes overboard, which is when the immune cells start killing anything in their path, including healthy cells. ARDS is often fatal. In critical cases, it can lead to respiratory failure, requiring advanced life support, and this is most likely when patients head to the ICU. ARDS treatment includes supplemental oxygen and mechanical ventilation. The goal is to get more oxygen into the bloodstream, since the lungs can't. When this treatment doesn't work, the lungs are basically too flooded to get any oxygen into your bloodstream. That's the cause of most COVID-19 deaths. And even when a patient survives this phase, they could be left with permanent lung damage. SARS punched holes in some infected people's lungs, giving them a honeycomb effect. And these lesions have been seen in people affected by the novel coronavirus too. Early studies found that most people who die of the disease will do so within 14 to 19 days. And on average, people who recover are released from the hospital after 2.5 weeks. But with the most critical cases, recovery could take months. Once a patient is in the recovery period, it's possible that they could still be contagious. These people should work with their doctors and public health officials to determine when they're no longer a risk. As of now, there is no vaccine for the virus, so the best way to avoid getting sick is to avoid being exposed. COVID-19 spreads easily from person to person through coughing and sneezing, so wash your hands often and avoid close contact with people who are sick, and clean and disinfect surfaces that you use daily. COVID-19 should be taken seriously, but most cases are survivable, so stay home, stay clean, and don't panic.
Hi, I'm going to show you some of the molecules coronaviruses use to infect human cells. So I'm particularly interested in Wuhan coronavirus, which is the cause of the ongoing epidemic in China and is spreading around the world right now. Let's take a look at what a Wuhan coronavirus looks like in electron microscopy. Okay. All right, so I have an image of these black arrows show two of the Wuhan virus, two copies of the Wuhan virus. And you'll see that it's a round particle, and on the outside, it has these spike molecules. There are these little fuzzy guys around the perimeter. On the inside, there's RNA, which encode the instructions of the virus. And the virus's goal is to get inside your human cells in your lung, to dump its RNA into your cells so that your cells can produce more copies of the virus. This strategy is not specific to coronaviruses. A lot of familiar viruses use these molecules that form spikes on the surface to invade human cells. Let's take a look at a couple other examples of that. This is an influenza virus example, and in the center is an influenza virus particle, and you see again the spikes, the little fuzziness along the outside. The two other things are just empty membranes. They're there to let researchers see how does the virus actually fuse with these membranes. So the idea is how does the virus fuse with the actual cell, but this is a simpler model of that. And we can see I can kind of slice through at different depths and at different angles. And if I get the right position, I can see where the virus is contacting this nearby membrane. It's formed this little cusp. It's going to fuse with it and create a hole so that the viral RNA, the genome, can be transferred into a cell. Let's look at one more virus that uses this same strategy of spike molecules on the surface. We'll look at HIV virus. So here are a half dozen HIV virus particles. One thing you'll notice difference, we see the membrane around the virus. It's spherical. Again, I'm cutting through it, and I can sort of slice in and out through the virus. And one thing we'll notice is that there are many fewer spikes. That influenza virus and the coronavirus were covered with the spikes. HIV virus is a little bit different. It only has tens of spikes. For instance, here's one, this little stub sticking out. Okay, so we're going to look at these spike molecules. They're used by the virus to recognize your cells and to enter your human cells in your lungs, the coronaviruses. In your lungs. We're going to look specifically at the spikes on coronaviruses. Okay, so here I've brought up some electron microscopy of human coronavirus, and it's looking kind of pale. Let me try hiding this and showing it one more time. Let me try to make the threshold. Okay, I just changed the threshold of this electron microscopy, the displayed threshold. So this is what one of these spikes looks like on a coronavirus. Okay, it's a human coronavirus. These human coronaviruses, there are 4 different strains that are known. They cause colds. It's a mild illness. They cause about 10% of the common cold, cases of the common cold. The virus would be here at the bottom, and this is the spike sticking up. So this is the top here is the furthest part away from the center of the virus. And this is what the electron microscopy looks. This more detailed view than what we were looking at a second ago was obtained by averaging images from like 10,000 different spike molecules to get a higher level of detail. And from this electron microscopy, we can figure out exactly what the molecular structure of the spike is. So let me show you that molecular structure. Okay, so here's what the spike looks like. And we have three proteins here. There's a green one, a blue one, and a red one. And they're actually all the same. They're three copies of the same one, and I colored them differently just so that we can clearly see the three. The spike is symmetrical. Okay, all three copies are more or less identical in their shape. The orange part I'm going to talk about a little bit later are sugars covering the spike, sugar molecules. And the really interesting part of this structure is the molecule that the virus uses to get into the cell is actually here. And it's this little tiny thing. It's a sialic acid molecule. And it fits in this little cavity in the spike. The little blue dashed lines, let's see if I give you a better bet. There's some little blue dashed lines. Those are hydrogen bonds. Those are attractive interactions between the sialic acid and the spike. Okay. When the virus encounters one of your cells, and your lung cells and other cells in your body are covered with these sialic acid molecules, it knows it's found your cell because the sialic acid molecule sticks here and triggers the initiation of this reaction, which is going to make the virus invade the cell. All right. So that's a human coronavirus that causes colds, not the Wuhan strain. Let's take a little closer look first at this sialic acid. It's a very small molecule. I just want to briefly show you that. Okay, it's this little speck here, only a few tens of atoms. It's a sugar, it's a monosaccharide. And you might think, and I guess another important fact, influenza virus invades your cells and recognizes your cells by the same molecule, sialic acid molecule. Okay, so that's interesting. You might think that other coronaviruses, well, they're in the same family as this human coronavirus, would also use sialic acid, but surprisingly, that's not the case. And so let me show you what the Wuhan coronavirus is recognizing, and also SARS, a virus that caused an epidemic in 2003, what it recognized. Oops. Okay, so let me try to get it. Where is it? Here it is. So Wuhan virus and SARS virus are recognizing this protein, which is, again, it's a natural protein in your body, like this sialic acid on the surface of the cells. This is called angiotensin converting enzyme 2, ACE2. There's also an angiotensin converting enzyme without the 2. Okay, this one with the 2 lowers your blood pressure. The one without the 2 raises your blood pressure. Both of them work. They have this groove. Let's see if we make this groove bigger. This groove here. Right in here. Both of them work by clipping a small angiotensin molecule. It's 10 amino acids long. The ACE without the 2 clips it from length 10 amino acids, angiotensin from 10 to 8. And that raises your blood pressure, and this ACE2 clips it from 8 to 7, and that lowers your blood pressure. So this is actually a good molecule. Both ACE and ACE2 are interesting targets for a lot of diseases, for high blood pressure, for diabetes, for heart disease. At any rate, we're not going to be able to avoid Wuhan coronavirus by getting rid of this. This is an important, good molecule on the surface of your cells. So how does the virus spike recognize this molecule? Let me bring up, I'd like to show you the Wuhan coronavirus, but we don't have a structure of it. So I'm going to show you SARS, which is the closest thing we have, the spike structure of SARS. Okay. And this is going to look like a lot like that human coronavirus, still the 3 proteins. The sugars aren't here, but they aren't shown here, but in fact there are sugars here. It was just in this particular model they didn't add the sugars. Those sugars are part of all the spikes, the coronavirus spikes. And what they saw when they looked at SARS is that these at the top of the spike, the virus would flip out part of it would make a small motion. Let me show you what that motion looks like if I can. So let's see, here we go. Okay, do you see this little green part at the top? It's called the binding domain. And it can move from a down position, where all three of them are down and kind of tucked in, to an up position. And that up position is the only position that can recognize this ACE2 molecule, the angiotensin converting enzyme 2. When they saw this in electron microscopy, they only would see one up at a time. Like the red, blue, and green are identical, but only one would be up at a time. They didn't see two up, they didn't see three up. They just sometimes see one up, sometimes see it down. Okay. When it's up, they also saw it bound to this ACE2. And it doesn't bind to just any old place on the structure. It's very specific on where it wants to stick to the ACE2. So let me show you exactly the correct location where it sticks. Okay, so here's the actually from the electron microscopy that shows the ACE2 in brown. Here's the spike, it's flipped up. When it's attached to the ACE2, what they see in the electron microscope is the thing is even more flexible. So let's see. There we go. Let me see if I give you a better angle that shows this motion. Okay, so the thing can swing in and out. And what they observe next is that half of the spike just falls off when the ACE2 attaches. This is in SARS. Okay, what the top half falls off. And here I changed the color scheme on you a little bit. The bottom half I colored light colors, light red and light blue, and this light green kind of looks gray. Each of these three copies of the protein is cut at a certain point, and I marked it in red where it's cut. A protease, another molecule, makes a cut right here, and that's totally critical. If the cut's not made, then the virus can't infect. Okay, so each of the three ones has a cutting point, and what they observe is this green copy, the top half with the ACE2 floats away, and then the red and the blue, they don't have ACE2, only one of them. These become unstable. They no longer stay attached, and they float away, and we're left with just this bottom light-colored portion of the spike. And this bottom portion in the middle exposes the mechanism which allows it to fuse with the human cell. Okay, is this what's going on in Wuhan coronavirus? So everything I'm showing you is for SARS. We don't have the structures for Wuhan coronavirus, but one thing we can do is we can look at the difference between this SARS virus and Wuhan virus, because we know the chemical structure of the Wuhan virus from its genetic code. So let me color the differences between the two. Let's see, I have a little button I made to do that. There we go. So I colored every part of this green molecule, 1/3 of the spike, orange if it was different between the Wuhan and the SARS virus. So you see, it looks like a lot of orange. It's only about 25%. It's about 75% identical, which is a high amount of identity. When two proteins in your body are 75% identical, generally they function nearly exactly the same. Okay, but it would be what we'd really want to look at here is sort of the really important part here where it's attaching to this ACE2 molecule. We see a lot of orange at the interface between the two. And that would make me suspect that this isn't quite right. Wuhan virus. SARS virus and Wuhan virus are probably a bit different here. And in fact, if I only had this evidence, I would probably think that Wuhan virus wasn't even using this ACE2. Okay, because there are so many differences right there. But experiments that were done in the last few weeks already confirmed that Wuhan virus indeed is using ACE2. Okay, but we can expect that our model based on SARS is going to be a little bit off because there are a lot of differences in the critical location where it binds. All right, I want to show you one last thing, and that is what can your immune system do to fend off this virus? So here's another structure. again, of SARS, because we don't have the equivalent one for Wuhan. It's the spike. And instead of the red, blue, green coloring, I made it all white because I wanted you to focus on this colored part at the top. Okay, the orange is the differences, all the locations where there are differences between the Wuhan virus and SARS. And at the top, these colored blobs are antibodies. These are things your immune system produces. These are fragment antibodies, like the light green and the olive. This is a light chain and heavy chain. An actual antibody in your body is about twice as big as this, but this is a fragment that they use in experiments because it's simpler to work with. So there are 3 antibodies, 3 pairs here. I've colored them differently, again, just to see, to easily distinguish them, but they're the same antibody. It's an antibody called S230. It came from a patient who survived SARS. And you see that it binds at the tip of the spike, right near where the ACE2 would bind. And this is a neutralizing antibody. And by covering the spikes of the SARS virus with the antibody, the ACE2 isn't able to bind, and then the virus isn't able to recognize cells and infect them. Okay, so this is a mechanism your immune system uses to fight off the virus. If it can't get into your cells, then it can't reproduce. All right. One other thing that I told you I was going to come back to was these sugars. And I've colored them pink in this structure, and they're all over the surface. And these sugars are a technique viruses often use to defend themselves against the immune system. Your cells in your body and proteins, molecules on the surface of your cells, like the ACE2, often have sugars coating them. And so your immune system does not generate an attack against sugars generally, because then it would end up attacking your own body. So the spike here has disguised itself with all these sugars. But the problem is, up where it needs to recognize the host cell, it can't put sugars there because they would be in the way. They would prevent the recognition with ACE2. And so that's a vulnerable part. And so that's where we see this antibody bound. Okay. When I showed you earlier that the tips of the spikes, the 3 copies were folded in, that may be a mechanism to disguise the virus from these antibodies and from the immune system. It keeps them folded in, hidden from view, and only occasionally flips them out to see if there's an ACE2 molecule nearby. All right. Let's see. I think that covers everything I wanted to tell you.
Wash your hands, and wash your hands. And when we're washing our hands, make sure that we wash for at least 20 seconds with soap and water, covering all surfaces of your hands, including in between your fingers and your fingertips. Next, if you need to cough or sneeze, be sure to either use a piece of paper and then throw it away, then wash your hands. Or if that's not available, cough and sneeze onto a sleeved elbow. Then try to avoid touching your face with your hands, whether it's your nose, your eyes, or your mouth. If you're sick, stay home, and if need be, call your doctor. At this time, we don't recommend people in general to wear masks. However, if you have symptoms of fever, cough, or shortness of breath, a mask can actually prevent yourself from spreading your germs or the virus to the public. However, a mask is no substitute for good hand washing. When a person would either cough or sneeze, and the infection, the virus, would travel from the droplets that is being sprayed out from the cough or the sneeze into the air, and if it were to land onto the other person's eyes, mucosa, or any surface, that's how it actually would be spread to another person. At this point, I would recommend that we don't shake hands or greet each other the traditional ways, because we want to avoid touching each other and share germs that way. However, there are other creative and fun ways that we can greet each other, simply by, let's say, doing the air high five and the air handshake, And of course, the traditional Chinese greeting where we just hold our hands together, smile, and say hi.
Blessings and blessings. The coronavirus. Oh yes, let's go there. So, I want to start by saying, if you resonate with this video, make sure you click the like button and you leave a comment below so that YouTube shows it to more people. This is my take. I'm going to call it the spiritual take, the conscious take on what is happening around our world as it pertains to the coronavirus. Now, secondly, I want to send my legitimately heartfelt prayers to anybody's family who has lost somebody to that. Same thing for anybody whose family has lost someone to suicide or a car accident, or let's take the statistics of mothers dying in the hospital in the United States of America, which is more than any other place on the planet, right? Or almost from a Western standpoint. There's a lot going on our planet, and it is very important that we keep our vibration, our frequency, our conversations upstairs. I have been alive long enough to have been around when the Y2K, the world will come to an end. Y2K, the whole world will come to an end at 12 midnight. The computers will crash. Everybody will crash into their cars and nothing will ever be the same. That was not true. I've been around for the mad cow disease and these different things that have been pumped and pushed towards us to keep our vibration and our frequency low. Let me remind all of us, there is only one truth on the planet, and that is love. There is no opposite to love. However, we live in a cause and effect universe where God, Buddha, Krishna, Jesus, Allah, source intelligence, whatever you want to name it, Google, whatever it is, if you say or type it in, it must say yes. So if you believe the fear mongering, the false evidence appearing real, if you believe that and allow it to penetrate and permeate your space, then your vibration lowers, which means your immune system lowers, and you are more susceptible to some of, let's call it the man-made viruses that are floating around. However, we need germs. Let me remind you of that. I would be considered maybe one of the dirtiest people you would meet, in the sense of I don't wash my hands all the time. I don't take showers every day. I don't do anything like that. Why? Because I know that this system, this beautiful, amazing skin suit that I call Preston, that you call Preston Smiles, was made in the spiritual image and likeness of the Most High, and it is perfect and functioning. All the man-made stuff that we've added to it, yes, beautiful, I'll take it. I'm in a car right now, I'll take it. I have a hoodie, a sweater on, I'll take it, yes. And I'm not gonna be so fooled as to believing that my whole existence is based on what's being advertised to me at the moment. God is real. Love is real. Keep your vibration and your frequency high. Where attention goes, energy flows. So let me remind all of you beautiful conscious beings out there to take your attention off of the fear and the lack and limitation and the scarcity and the woe as us, and bring it back to love. This is not being stupid. Because there's a difference between being careful from fear and being aware from love. Oof, let it land. Hurrah! There is a difference. I'm going to say it again. From being careful from scarcity, lack of limitation, not enoughness, and being aware from peace, joy, harmony, and abundance. Hurrah! That is the game you want to be up to, especially right now. Because We don't know what's being set up. And I don't want to go too far into conspiracies or anything of that nature. However, do I trust the government fully? Psh, of course not. Of course not. They make alcohol readily available everywhere. Porn is being pushed into every community they can find. Opioids are going crazy. Do I trust the government to have our backs completely? Any government? Nope. I'm a sentient being. It is my duty, my job to stay woke. I love you. Please leave a comment with whatever landed or resonated. If it did, if it didn't. All I ask is that we be respectful and we be nice to each other. Okay? So if you are mean and you have mean comments and you call me names and things like that, I'm going to delete you and block you. I love you from my heart, even if I delete you and block you. Please, vibrations high. It's all good. And it always has been. And it always will be. Don't believe the lie. There is a virus of the mind that is being spread that is way, way deeper and crazier than the collection of viruses. It's a collection, including the common cold, called the coronavirus. Peace and blessings.
You know that the best way to prevent the spread of coronavirus is to wash your hands.
Wash your hands.
Wash your hands!
But why? It's because soap, regular soap, fancy honeysuckle soap, artisan peppermint soap, just any soap, absolutely annihilates viruses like the coronavirus. Here's how. This is what a virus, like coronavirus, looks like. It's a bit of material surrounded by a coating of proteins and fat. Viruses easily stick to places like your hands, but when you rinse your hands with just water, it rushes right over the virus. That's because that layer of fat makes the virus behave kind of like a drop of oil. You can see it happening in this demonstration. Oils are just liquid fats. What happens when you pour oil into water? It floats. It doesn't mix. But add soap, and suddenly that fatty oil dissolves into the water. That's because inside, soap has two-sided molecules. One end of the molecule is attracted to water, the other end to fat. So when the soap molecules come in contact with water and fat, these dual attractions literally pull the fat apart, surrounding the oil particles and dispersing them through the water. Let's go back to our coronavirus molecule with that layer of fat holding everything together. When it interacts with soap, bam, that fat gets pulled out by the soap. Soap literally pulls apart and demolishes these viruses. And then the water rinses the harmless leftover shards of virus down the drain. But, and you know where I'm going with this, it takes time for this effect to happen. 20 seconds to be specific. To show why, we ordered this lotion that mimics viruses and their fatty layers. It glows under a UV light. If you just rinse your hands under regular water, nothing comes off. If you wash with soap for just 5 seconds or 10 seconds, your hands are still covered. The virus is still there, able to get you and others sick. But 20 full seconds, now the soap is actually destroying the virus. Hand sanitizer works too because it's mostly alcohol, and alcohol works in a somewhat similar way to soap, breaking down that fatty layer. You need a high concentration of alcohol to make that work. The CDC recommends hand sanitizers with at least 60% alcohol. But even with 60% alcohol, the CDC recommends using soap if you can. If your hands are sweaty or dirty when you use the sanitizer, that can dilute it and diminish its effectiveness. As for soap, just any old soap works. You don't need soap marketed as antibacterial even. The FDA says skip it. There's no proof it's any more effective. Just be sure to wash your hands for 20 seconds. That's happy birthday twice. Happy birthday, dear. I guess me. Or the chorus to Lizzo's Truth Hurts.
Straight to my face.
Or Prince.
Raspberry beret.
Or Eminem.
Go, go, only go.
Or even Dolly.
Jolene, Jolene, Jolene.
Just as long as it's 20 seconds. And you're using the ultimate virus annihilator, soap.